Okay, so let's look at that first problem they gave us. They wanted us to write a sine function given this information. So here's the generic sine function. And just like we graphed, the very first piece of information we looked at was the amplitude, wasn't it? And where's the amplitude always located? Yeah, it's located as the coefficient of the trig function itself. So they told us the amplitude was 6, didn't they? Okay, well then that means that my a equals 6, which means my equation is going to look like 6 sine of x, won't it? Good. The next piece of information that we looked at after amplitude was the period, correct? Now remember, to find the period, it was 2 pi divided by b. Now what did they give us? They gave us the actual period, didn't they? That's the p. So they actually gave us the period. So since they gave it to us, are we able to find the b? That's supposed to be the coefficient of x. Yes, we can. So you guys work on your algebra. I'll work on my algebra. And it looks like b is equal to 2/7, which means my equation is now expanding. It is going to be y equals 6 sine of 2/7 x. Got it? Okay, the last thing is the phase shift. Now, here's the deal with the phase shift. This tells me that x was equal to 1/3, right? That was a positive 1/3. I shifted to the right 1/3. Since this is positive, that means it went to the right 1/3, which means in the parentheses, I should find x minus 1/3, shouldn't I? Right, because when you set that equal to 0, the normal start, which was 0, then you're going to get a positive 1/3. Now, the authors of the book show how to incorporate this phase shift a little bit differently than how I do it. So just watch what happens. So now we have y equals 6 times the sine. We still have the 2/7, right? Now, the way I have found to be the easiest and the most straightforward way of incorporating the phase shift is to have 2/7 in front of the phase shift parenthesis. And then when you distribute, the 2/7 will be distributed inside. Notice the 2/7 is the coefficient of x, right? But when you distribute it to the 1/3, it becomes 2/21. And you're like, okay, well, how do you see a phase shift of 1/3? So remember, here is your check on the phase shift. If I take the 2/7 x minus 2/21 and I set it equal to 0, I better get my phase shift of 1/3. I better get a shift to the right of 1/3. So we would move over that 2/21, right? And then you would multiply both sides by 7/2, wouldn't you? So those cancel, the 2's cancel, the 7 reduces with the 21, which will give me x equaling 1/3. So that does check. So you have found right here the sine function given this information. Cool? Hang in there. I got another one of these. Okay, so once again, they gave us this particular information and they still want me to write a sine function. So remember, we start the same way we started when we were graphing. The first thing we identify is the amplitude, which is 4, and that's the a, isn't it? So I already know my function is looking like 4 sine of x. And then the next thing we looked at was the period. Remember, the period is 2 pi divided by b. They gave me the actual period, didn't they? They didn't give me the b, they gave me the actual period. So when I plug it in, I'm able to find the b, am I not? So you do your algebra, I'll do my algebra, and I come up with b equaling 1/4, which means my sine function is now evolving. So it looks like 4 sine of 1/4 x. So far so good? Last but not least is that phase shift. This phase shift tells me that it went left 1/8, which means x was equal to a negative 1/8. And when I work backwards, that means in the parentheses was x plus an eighth. So when you write that, so my equation is evolving, we have y equals 4 sine of 1/4. Now again, I find this much simpler to do than how the authors explain it. X plus 1/8 is in that parenthesis. And yes, you're going to have to distribute that 1/4. That 1/4 needs to be the coefficient of x, and now it is. But on the back side, this is going to be 1/32. Got it? And you're like, do I get a negative 1/8 phase shift? Well, check it out. Do we? Let's check the phase shift. If I take the 1/4 x plus 1/32 and I set it equal to 0, let's solve for x. And I have to multiply by this reciprocal, agreed? Yep, looks like I get x equaling a negative 1/8. So that's good. So here is my sine function for this information. Good? Okay, so we're going to get into some stories. And these stories are actually going to ask us to find the sine function. So what we've done here is going to help us solve those stories. So hang on. Okay, so we just looked at a problem where they gave us temperatures for a city in Alaska. And the first thing they're asking us to do is to create a scatter diagram. So, look back at a previous lecture of how you input your data. My suggestion is to be very careful of the windows. They told me my windows are 0 by 13 and 0 to 60, all right? They didn't give you the scale, but look at one of those scatter plots that they did give you as an example, and you can figure out the scale for the x's and the scale for the y's. So I got C as an answer when I did my scatter plot, when I inputted the data into the calculator. Now, there is a part B to this question, and the part B is they want us to create a sine function for that data. And you're like, you're kidding. Nope. They want us to create a sine function for that data. So the input was the months, right? But you don't input January or February or March. You input 1, 2, 3 all the way down, right? And the temperature was the output, right? Okay, so now we need to come up with this sine function. You're like, well, how do you do it? We do it the same way as when we were graphing. We need to come up with the amplitude first. So, I'm going to sidetrack you a minute, okay? Let me sidetrack you over here. What happens if you had y equaled 3 sine of x? Your amplitude is what? Good, your amplitude is 3, which told you your range went from a negative 3 to a positive 3. Agreed? Now, here's something we need to observe, because this observation will be helpful for us to actually go backwards and find the amplitude when all they gave us, which was a bunch of data, right? Okay, so the distance between these two numbers is, good, 6. And the distance is found by taking the larger number minus the smaller number. That's how we got a distance of 6, correct? Now this distance between the two numbers is twice as large as this 3, isn't it? So if I took this distance and I divided it by 2, wouldn't I get this amplitude of 3 that's in the front? Yes, I would. Now, as a reminder, amplitude deals with the y's, doesn't it? Because the amplitude talks about the range, doesn't it? Right? We have to remember, and it was done in a previous lecture when we were graphing the sine and the cosine functions. In that last slide I showed in that previous lecture, I went through those characteristics again and I made sure and identified which one were the y's and which ones were the x's. The amplitude is the y's. So when I'm looking at the largest minus the smallest, I'm looking at the largest y value minus the smallest y value. So to find the amplitude, you're going to take the largest, remember we're talking about y's, and subtracting the smallest, and then you'll be dividing by 2. So in this particular case, my largest is 56.2, and I'm going to subtract the smallest, which is 25, and then I'm going to divide by 2, which tells me I have an amplitude of 15.6. Cool? Did you get the same thing? I hope so. And all I did was observe what happened when I was actually graphing a sine function. Okay? All I did was go backwards. Okay, so next on the list is the period, isn't it? And the period is supposed to be 2 pi divided by b. Well, let's take a look. They didn't give me the b. Clearly they didn't give me the b. But the question is, did they give me the period? Oh, I'm sorry. I forgot to mention one thing. You know, after we determine the amplitude, we ask ourselves if it flips. Always. No. You always say no. Always. Okay? So, sorry about that. So now I'm going to look at the period. Good? So here's the thing. The period was for a year's time, wasn't it? Because they gave me 12 months. So the period is 1 year or 12 months, right? So which one do you think we should put it in? A year or 12 months? Good. Put it in months because they literally listed out the months for us. So in this particular case, we should have 12 equaling 2 pi divided by b. You do your algebra, I'll do my algebra, right? So I get b equals pi over 6. Did you get that? Okay, after the period is the lowy. You're like, how does the lowy help us? Well, hang in there. The lowy is going to help us. Now remember, this deals with our x's. So, the lowy is the period, which was 12 months, divided by 4, which is 3 months, right? Okay, I'll get back to lowy in a second, so hang in there on lowy. Okay, vertical shift was next, and the vertical shift is the y's also, just like the amplitude is the y's. Now, the formula to find the vertical shift is extremely similar to find the amplitude, except in this case, you're going to take the largest added to the smallest, and then divide by 2. So I'm going to take my 56.2, I'm going to add the 25, I'm going to divide by 2, which means I have a vertical shift of 40.6. Good? And last but not least is the phase shift. Now, We're like, well, do we have a phase shift? I'm going to tell you right now. The phase shift, which also deals with the x's, is directly connected to low E. Directly connected to low E. Let me show you why. My low E is 3 months, right? This is in months. My low E is 3-month intervals because my period was 12 months. That's why the unit's in months. So I still have 4 intervals, 0 months, 3 months, 6 months, 9 months, and 12 months because it goes in increments of 3, right? This is a sine graph they're asking us to look at. They're trying to ask us to find the sine function. So I know the sine graph looks like the mountain to the valley. Agreed? Okay. So here's the deal. This is why low E is extremely important when we're going backwards. This graph shows me that the max occurs at 3 months with no phase shift. The max occurs at 3 months with no phase shift. Look at your data. Your data shows you the data shows that the max occurs in month 7. The data shows me that the max occurs at month 7. No phase shift tells me the max should have occurred at 3 months. Well, if it should have occurred at 3 months, but it happened at month 7, that means I do have a shift. I have a shift to the right of 4 months. Are you with me? I have a shift to the right of 4 months. Cool? Okay. So now, I need a little bit of board space so I can start writing our equation down, our sine equation. I'm going to erase low E here. But remember why low E was important, because low E helped me find the phase shift. It goes with the x's. Okay. So, remember your generic sine function. A is the first one, right? A is in front. And if you need to look back at the previous couple of examples where I wrote the generic, then look back at the previous couple of examples. Or actually, I think I have space. I can write this here. Okay. So, my amplitude, 15.6. My B, pi over 6, right? My phase shift was to the right 4 months, which means in the parentheses is x minus 4. Remember, if this equals 4, then when you go backwards, it's x minus 4. And then plus the c plus your vertical shift, which 40.6. And when you finalize it, y is equal to 15.6 times the sine of pi over 6x plus 4 times pi over 6. Yep, you're going to have to reduce that. Whoops, and it's not a plus, excuse me. It is a minus. Sorry about that, guys. See, this is why I need you doing it with me. 2 pi over 3 plus 40.6. Cool? This is the sine function that goes with that data in Alaska. So now, x is the number of months. They could give me any months they wanted. I would plug it in and it would give me the temperature for that month. Good? Okay, so hang in there. We've got one more problem to work. Okay, so let's look at this last problem. you've already read, or we've already read, that we are dealing with the National Oceanic and Atmospheric Administration. And they've given us the low tides, the high tides, they've given us the length of time between consecutive high tides, all that great stuff. And the first question they're asking us is, they would like us to use the given time between consecutive high tides to approximate when the next high tide will occur. Well, help me out here. They told me that the time length between consecutive high tides is 12.5 hours, didn't they? They also told me that high tide occurred at 3:39 a.m. And they're like, okay, so tell me, when's the next high tide? So here's the deal. Here's one of the things that we're assuming. If we say one of the high tides occurred at 7 a.m. If the next high tide was 12 hours later, what's 12 hours later from 7 a.m.? Good, 7 p.m., right? It's exactly the same time, except it's now in the p.m., it's now in the evening. So here's the deal. If I take my 3:39 a.m. and I add 12 hours to it, then we are going to end up at 3:39 p.m. Yes? But then I need to add another half hour to it, don't I? I need to add another 30 minutes to it, don't I? Which would put us at 3:69 p.m. Well, that's kind of odd. 69 p.m.? That's 60 minutes plus another 9 minutes, isn't it? So you've got 60 plus 9 minutes, don't we? Well, this 60 minutes is an hour, isn't it? So 3:69 p.m., that's 4:09 p.m. Cool? Okay, so hopefully you knew how to do that, but I was giving you a little run through to make certain that in case you weren't sure how to do it, this is one way of doing it. Cool? Okay, now they want us to come up with the sine function. And you're like, wonderful. So here's the thing. We already did it in the last problem, right? It's the exact same approach that we're going to work in this problem, except our data is a little different. So, what's the first thing we find? Yes, amplitude. Amplitude deals with the y's. So, we need to know what's representing the y's. Is it the time that's representing the y's, or is it the height of the waves that's representing the y values? Good, it's the height of the waves that's representing the y values. So, based upon what we've already done, to find the amplitude, you're going to take the highest wave, which was how many feet? Good, 8.8 feet. And you're going to subtract from it the lowest wave, which they said was actually a negative 0.4 feet, right? Divided by 2. And I know some of you are asking, how do you get a negative 0.4 in a wave? Well, if you've been to the beach, and I'm sure most of you have, and you just stand by the water, and you just sink your feet a little bit by the water, as the waves come up, don't they like pull the sand away from your feet and it almost feels like you're sinking? Yeah, so it's going below like the ground zero, shall I say. That's how we have a negative 0.4, because the waves are pulling away the sand. Good? Okay, so I know some of you've got your calculators out and you're working on this And some of you actually have already worked on it and you have your answer. So, I got 4.6 for my amplitude. Did you? I hope so. By the way, the next part is asking if it flips. That's always a no. Remember that. Okay. What's next? That's right, the period. And the period deals with the x's. Remember, the period is 2 pi divided by b. Now, did they give me the value of b? Of course not. We have to find it. Did they give me the period? Yeah, they did. Because they told me the distance between consecutive high tides, didn't they? What was the distance between consecutive high tides? Yeah, it was 12.5 hours, right? It was 12.5 hours. So they gave me the period was 12.5 hours, which means we have a way of finding B. Now, I'm going to suggest you take 12.5 and make it into a mixed number and then an improper fraction, because I'm dealing with a fraction on the right side. So if some of you are like, well, how do you do that? Because you had forgotten, follow along. So 12.5 is 12 and a half. 12 and a half is 25 over 2. With me? And then I get to cross multiply because I've got a proportion here. So I have 25b equals 4 pi, and then b equals 4 pi over 25. The key was making this decimal into a mixed number and then an improper fraction. Good? Okay. What else do we find after the period? Yeah, we find the LOE. And since my period is 12.5, I'm going to divide by 4, which means my length of each interval is 3.125 hours. Cool? Okay. What's next after the period and the LOE? Yep, the vertical shift. Remember, the vertical shift also deals with the y's. The vertical shift is extremely similar to the amplitude formula, except instead of subtracting the largest and the smallest, I'm actually adding the two of them together, which means I get a vertical shift of, good. Sorry, I sidetracked a second. 4.1. Nope, 4.2. I don't know where I was going there. Good. Cool? All right. After the vertical shift comes the phase shift. And remember, the phase shift is also an x. What helps me find the phase shift? Yeah, LOE. LOE and the phase shift are connected. Okay? LOE and the phase shift are connected. So here's the deal. Let me go back to LOE. It's a sine function. I have 4 intervals, each with a length of 3.125, right? Okay, so I know sine is the mountain to the valley. Based upon this graph, with no phase shift, the max is at 3.125 hours. That's what LOE is showing me. With no phase shift, the max is at 3.125 hours. That's what it's telling me. However, the data told me differently. The data states the max is at 3.6500 hours. That's why they gave it to me in decimals, the hours in decimals. They told me it was at 3.6500 hours. There's your max according to the data. Below he says it should happen here. So do I have a phase shift? Oh, I most certainly do. And it is to the, good, it is to the right. And you do your subtraction. I've already done mine. It's to the right by 0.525 hours. Cool? Which means x equals 0.525 hours, which means the parenthesis had x minus 0.525, didn't it? Okay, with me? So if you're not, stop, rewind, play again. That's the advantage of a video. So I am going to erase Loey because I need some board space to help me write my sine function. Okay. So some of you may benefit from writing the generic sine function so you can see it, so you know where everything goes. And again, the authors of the book, some of them use the Greek letters of the alphabet versus our normal English letters that we're used to, the Aramaic letters. So just saying, know the location. Okay, so here we go. Y equals A, 4.6 times the sine of B, which was 4 pi over 25, times the phase shift, which is x minus 0.525, plus my vertical shift, which is 4.2. And now you have to distribute this fraction into that parenthesis. Now, I know this is it's going to be a combination of fractions and decimals in the parenthesis. So I have 4 pi over 25 times x minus. Now, since the phase shift is a decimal, you're going to have to make the final answer in here a decimal when you distribute this 4 pi over 25 to this decimal. And 4 decimal places is what I'm going to ask for. And I got 0.2639. Oh yes, plus the 4.2. We have to remember that. Cool? Here is your sine function. X is the time, y is the height of the waves. Cool? Okay, so hopefully these last 2 problems made some sense to you. If not, please go back, rewind them, stop them, play them again as many times as you need to. So, as always, you guys have fun with this stuff, and I'll catch you on the flip